Hi everyone, I have first order linear differential equation here, the third and final example. We have tan x dy dx plus 2y equal to x cosec x. So how do we use the integrating factor to find the solution of a first order linear differential equation? So I've done an introduction for this. If this is the first video you are seeing under this topic, locate linear first order differential equation in the playlist Engineering Maths 3 Laplace Transform and Integration. So let's see what we have today. Please subscribe to this channel for further updates. So previously we learned that the form of linear first order differential equation is dy dx plus py equal to q, and we all agreed when we did the introduction and those examples that the function p and q are two separate functions on their own in terms of the variable x alone. So I was saying that we can use different variables to represent these two functions, either m and whatever variable you want to use. So we have to arrange the equation given to us in this form, dy dx plus py equal to q. So we already have q here. We have the y function, but we have a tan function here that we need to remove. We call it a trig function. We need to remove it by dividing through to make dy dx stand alone. Let me explain it that way for you to understand. So let's make dy dx be on its own by dividing through by tan x. So we have tan x dividing tan x dy dx plus 2y over tan x, giving us x cosec x over tan x. So we can now take care of this one and we are left with dy dx plus, so I can factorize 2y outside, 2y times 1 over tan x equal to x cosec x times 1 over tan x. So I'm applying 1 over x so that I can change the form of this function using identities to make it easy for me to be able to integrate. So now 1 over tan x is the same as 2y over tan x. This time this over that. So the next step is to change this to make it easier. So you need to look at the question very carefully before you tackle it. So we can switch to identities. We know that sine x out of cos x equal to tan x. So when I reciprocate this one, I'll get 1 over tan x. So therefore cos x over sine x equals 1 over what? Tan x. Now this 1 over tan x is the same as cot x. So cot x is the same as 1 over tan x at the same time equal to cos x over sine x. I am interested in this. So we are going to use this form to complete the curve because I can't use cos x sine x. It will be difficult for us to integrate this. So now I will switch this side to cot x. So we have dy dx plus 2y cot x equal to x cosec x times cot x. If you are still confused here, I have done an acronym that will help you remember some of these trig functions and its identity. So you need to look at it. It's very helpful. It will help you to recollect this type of functions, some few of them, and its various identities. So locate this in the playlist acronyms and how to remembering trig functions. So let's move on. So once you get here, you label the function as a certain equation. So I'm using equation star. So from here, we need to find the integrating factor and use the integrating factor to multiply through equation star. So how do we find the integrating factor? All you need to do is to compare your equation star with linear first order differential equation. So compare equation star with dy dx plus py equal to q. Now we can compare. We have dy dx is here. We have y to be here. Now we have 2 cot x to represent the function p. So I told you that function p is a function in terms of the variable what x, then everything we have on the right side equal to what? Q. So we can write that P equals 2 cot x. Then Q equals x cosec x times cot x. Now your next step is to find the integrating factor. So if, which is the integrating factor, is equal to exponential function integral of p dx. So the integrating factor is e to integral of p dx, where p is the function that is multiplying the variable y, So don't forget that. So now, what is our p function? We already have it, so we can substitute it there. So we have our if equal to e integral of 2 cot x dx. Your next step is to be able to integrate the function that you have here. So we can rewrite this in the form if equals e 2 integral of cot x dx. Remember that if you have a variable there is no need. Factorize the variable out and integrate the function. We can then use the variable to multiply through when we are done. So now, what is the integral of cot x? So integral of cot x is if equal to e2. Now when I integrate cot x, the result is ln sine x, natural log of sine x. So you need to learn how to integrate trig functions. Okay, so you can locate my video in the acronym playlist, integrating trig identities. You see this one there. So we can move on. This is giving us if equal to e. Now the two can multiply the function 2 ln sine x. Now these two can be raised to a power here for the sine. So I can rewrite this as if equal to e ln sine square x. This is similar to what we do in logarithm. So like we do in logarithm, we pick it here and we raise it to say it's a rule. Now, after we get here, ln can now cancel the exponential function. So anytime you raise an exponential function to the natural log, they will cancel each other and you'll be left with whatever function you have there. So we have our if equal to sine square x. So now I have been able to solve for the integrating factor. Your next step is use the integrating factor to multiply the equation star, your main equation. So you use it to multiply through, because the solution for a linear first order differential equation can be found by multiplying through by the integrating factor. So let's do that. So let's multiply equation star by if. So to do that, we have sine square x times dy dx plus sine square x times 2y cot x equal to sine square x times x cosec x dot cot x. Okay, so once you are done multiplying through, your next step is to consider the left hand side of the equation and take the derivative of the integrating factor and the variable y. Remember that in the introduction, we learned that the derivative of the integrating factor and the variable y would generate the left hand side of the equation. So when we differentiate sine square x and y, we will get back the left hand side of the equation. So taking derivative on the left hand side, we have d dx of what? The function y sine square x. Okay, so now once you take that derivative, you equate it to the what? To the right hand side. So we have sine square x dot x cosec x dot cot x. Now remember that the derivative of this side generates the left hand side. I've already explained that. Now from here, you can now integrate both sides of the equation, both the left and the right. So we apply integral on the left hand side, d dx y sine square x equal to integral of sine square x times x cosec x times cot x. So now The integral on this left hand side, this will now take care of this, and it's out. We are left with y sine square x equal to integral of sine square x dot x cosec x times cot x. The dots here are just multiplication sign I'm applying. I don't want to use times. Now your next option is to make y the subject of the equation. So I can divide through by sine square x. So this is giving me y equal to integral of x cosec x dot cot x. Now remember that I have not integrated the right hand side because it is a complex function. So here we can leave our final answer here. The reason is that to integrate the right hand side, you need to apply integration by parts. This is because we have three different functions: the function x, the function cosec x, and the function cot x. You will not be able to finish today. It is a very tedious calculation. So all you need to do is to leave your final answer here. So when you get here, I'm not sure you will be marked down or you'll be marked wrong. So this is the end of this solution. You can leave it here. But if the function is not as complex as this, like the previous examples I did, then you can integrate the right hand side plus the constant of integration. Then you end it there. In the next one, I will be talking about Bernoulli's equation. So Bernoulli's is similar to linear first order differential, but there is a slight difference. So stay tuned and I will see you in the next one. Please subscribe to this channel if you have not. Thank you.